Guys, today what we are going to do, we are going to do some curl properties from last year. So basically what we are going to talk about the gradient. How do you find the gradient? And how do we find the turning point? That's basically our year 12 topic, all right? Okay, when you look at this one, you can see a happy parabola, a positive parabola. And at that point, we call it as the vertex. You know that one, we call it as the vertex. And we call that one as also, we call it as a stationary point. We know that also we call it as a turning point. We call it as a turning point, or we call it as a stationary point. We call it a stationary point. Now we are going to use calculus to find the turning point. To find the turning point, what we do, we know that at the turning point, y dash is equal to 0. At the turning point, y dash means you find the gradient of the function, that curve, that gradient will be 0 at the turning point. Gradient will be 0 at the vertex, or at the turning point, or at the stationary point. What type of turning point is that? You know, there are two kinds of turning points, maximum turning point and the minimum turning point. So this one is a positive parabola. So the turning point here, the nature of the turning point will be, it will be a minimum turning point. So that one will be a minimum turning point. Remember, how do you use the calculus to find the turning point? So you differentiate twice and it will be greater than 0. When you differentiate that function again and substitute x is equal to 0, or if you get a positive number, that turning point will be a minimum turning point. Okay, this is all from last year. Look at that one, that is a sad parabola. It also has a turning point. We know that at that turning point, gradient will be 0. As usual, the gradient will be 0. And what type of turning point is that? That will be a maximum turning point. That means you differentiate it one more time, so you get a negative number. If you get a negative number, that turning point will be a maximum turning point. You have to show calculus to find the nature of the turning point. Right, okay. Now we are going to talk about the gradient from last year. How do we find the gradient? We use the same method. That means we differentiate it. We differentiate once. For example, look at that example given. That's a positive parabola. Equation of that parabola is given as y is equal to x squared. That's a basic standard parabola. So we are going to find the gradient at the point. Let's say x is, we are going to find the gradient at that point. We are going to find the gradient of that point at x is equal, y is equal to x squared at x is equal to 1. So what do we do? To find the gradient, we differentiate it once. So when you differentiate it, we get 2x. Then we are going to find the gradient at x is equal to 1. We are going to substitute x is equal to 1 there. Substitute x is equal to 1 here. Then gradient is equal to 2. Remember, that is from last year's achieved question. To find the gradient, you differentiate once, then substitute x is equal to the value of x into the equation, we find the gradient. To find the turning point, you differentiate it, make that equation is equal to 0, solve for x, you get the x value of the turning point, then substitute that x back into the original equation, you get the y value of the turning point. Differentiate it one more time. If you get a positive number, that will be a minimum turning point, and if you get a negative number, that will be a maximum turning point. You may get one achieved question using one of these methods, most probably to find the gradient. Definitely we are going to use product rule or a quotient rule. It will be an exponential function or log function, something like that, right? Okay, let's do some examples. Find the gradient. Find the gradient. First one, y is equal to x squared minus 6x plus 3 at x is equal to 2. We are going to find the gradient of this equation, y is equal to x squared minus 6x plus 3. When you look at the equation, you can see, look at the sign before x squared, it is positive. That means it is a happy parabola. That is a positive parabola. And that is a turning point, right? And the gradient will be 0. When you differentiate it, you get a minimum turning point, you get a positive number. Okay, we are not talking about the gradient, the turning point, we are going to find the gradient. How do we find the gradient? This is last year's achieved question. To find the gradient, differentiate it. When you differentiate it, you please start practicing dy over dx. So dy by dx is when you differentiate it, 2x minus 6. this one is a gradient function or a gradient equation. Now what we do, substitute x is equal to 2 in y dash. Therefore gradient at x is equals to 2 equals, so 2 times 2, that is 4, 4 minus 6, that is equal to negative 2. The gradient will be negative 2 for this one. Okay. Now we are going to find, let's do one here, 13 question. Number 2. Y is equals to x sine x plus 2 at x equals to 2. We are going to find the gradient of this function y is equal to x ln x plus 2, right? Okay, what we are going to do here, can you see that one? We are going to use product rule. We are going to use product rule. We are going to differentiate that. Okay, let's, f is equals x, g is equals to ln x. We are going to put g is equal to ln x. F dash is equals to 1, g dash is equal to 1 over x. Now we are going to put it in the formula here. F dot g dash is equals f dash g plus g dash f. That's equal to, f dash is equal to 1, g is equal to ln x plus g dash is equal to 1 over x plus f is equal to x. Alright, that's we have differentiated this one plus, when you're differentiating 2, it became 0. Right, let's tidy up. X and x is getting cancelled. We have ln x plus 1, that is y dash. That means we differentiated, we have ln x plus 1. Now we are going to calculate the gradient at x is equal to 2. Substitute x is equal to 2 in y dash. So then you get ln of 2 plus 1. Use your calculator. Use your calculator. You're going to find ln of 2. Ln of 2, that is 0.69 plus 1, that's 1.69. We have 1.69. That is a gradient of that curve. Okay, let's do one more. Number 3. Y equals e to the power x divided by x, and we are going to find x is equal to 2. Alright, okay, when you look at this one, we are going to use quotient rule here. Alright, so we have f is equal to e to the power x, f dash is equal to, we get the same function, we use chain rule times 1, g is equal to x, g dash is equal to 1. Okay, let's check it in the formula. F over g dash, or we can call it as y dash, is equals to f dash g minus g dash f divided by g squared. Let's substitute the values. F dash is equal to e to the power x, g is equal to times x, minus g dash is equal to 1, f is equal to e to the power x, divided by g squared is equal to x squared. Let us tidy up. When you tidy up here, take e to the power x as common, you have x minus 1 divided by x squared. That is the gradient function. Now we are going to find the gradient at x is equal to 2. What we are going to do, we are going to substitute x is equal to 2 here. You get e to the power of 2, take away 2 minus 1 divided by 2 squared. That is equals to e squared divided by 4. Use your calculator. When you calculate the value of e squared, you can get shift e squared, you get 7.389. You divide that one with 4, you got 1.87. That is a gradient function. Alright, thank you. I'll set the work.